Hey, eighth graders, I hope everybody's doing well. Know you're counting down the days to summer just like I am. I'm tired. I'm ready for some free time. I know you are too. I'm going to just jump right in today. You had a great lesson from Miss Mathis on biotic and abiotic factors in an ecosystem. Today, I'm going to focus on the flow of energy through an ecosystem. And of course, we all know that food is how we get our energy. So that's what we're talking about. When we talk about the flow of energy through ecosystems, it's about food. So our objective today is I will identify the different trophic levels within an ecosystem and explain the flow of energy through them. So we know that the sun, is the ultimate source of energy for all living things. Plants take in sunlight, perform photosynthesis, they make their own food, which is a sugar called glucose. They store some of that and they use some of that to be converted into energy for growth and repair of plant tissues if they get damaged. We get this glucose or sugar when we eat fruits and vegetables. So, but it all begins with the sun. Boy, we be in trouble without the sun. And of course, we know through photosynthesis, oxygen is also produced. That oxygen is required for that process of cellular respiration, which is how our food is turned into that chemical energy for all of our life processes, for growth and for all of our body systems to work and for us to do any physical activity. It all goes back to Mr. Sun right here. Unless there's organisms that live on the deep ocean floor around those hydrothermal vents where it's so deep that it's dark that no sunlight ever reaches there. And weird things live there, but most things on the planet get their energy ultimately from the sun. So as organisms feed on one another, energy is passed from organism to organism in the form of food. We know food provides fuel for all of our life processes, building materials, and that process where our food is converted into energy, we know is cellular respiration. All right, so the flow of energy. I don't know where to put me. Maybe I should be nowhere. Energy constantly moves through an ecosystem from one organism to another in the form of food. And this flow of energy can be described in food chains, food webs, and ecological pyramids. The simplest of these is your food chain. So you can just kind of see, how we start with our producers, which are our plant material or our green things that photosynthesize. I look at the letter P. Producer starts with the letter P. So does the word plant. So does the word photosynthesis. So does the word phytoplankton. So your producers are your plant material, such as grass. So grass gets eaten by a grasshopper. A grasshopper is considered a consumer, but it's an herbivore, meaning it will only eat plant material. Grasshoppers are not going to eat other insects and things. So your primary consumers are herbivores, eating only plants. The grasshopper might be eaten by the toad. Well, if Mr. Toad here eats a grasshopper, then that's going to make him a secondary consumer. He really doesn't want plant material, although he might eat some. Some of these secondary consumers are omnivores, like a bird might be right here. Well, we know if this were a bird instead of a toad, the bird would eat a grasshopper, but birds would also eat seeds. So your secondary consumers may be omnivores as well. And the toad might be eaten by the snake. The snake might be eaten by the hawk. And then when any of these things die, we know that decomposers take over and they break down dead things into nutrients that just go back into the environment, into the soil, into the environment. So decomposers are important. So that's a food chain. That's easy enough. All right, trophic levels. Each level of organism in the transfer of energy through an ecosystem is called a trophic level. And you guys learned about heterotrophs and autotrophs back before school even closed. So you know that trough means nourishment or food. So I always picture pigs eating out of a trough. This thing right here that their feed is in is called a trough. So pigs eat out of a trough. Most of the time they eat out of a trough, but sometimes once they eat everything up, they decide they just gonna lounge around, take a little nap, soak up some rays. Anyway, I just thought that was cute. Organisms in each trophic level obtain energy from food, and then they use most of that energy just to survive, just to stay alive and do the things they need to do. Some of that energy gets lost to the atmosphere or the environment in the form of heat. We even give off heat. We emanate heat. And some energy is stored. And because organisms use so much energy just to stay alive, they don't have much that they can pass up to organisms higher up on the food chain. Okay. All right. Our first trophic level are our producers. These are the bottom of the food chain. And so these are your plants and things. These are your autotrophs. Auto means self, troph means nourishment. So these are self nourishing, which means they make their own food, self feeding. So these are your plants, your phytoplankton, all the green stuff. They are the base, the foundation of a food chain. Your second trophic level are your primary consumers. They're heterotrophs, hetero meaning different, troph meaning nourishment. These are organisms that have to get their food from a different source other than themselves. So they have to eat other things. Primary consumers, though, eat only plants. So at your second trophic level, your primary consumers, they're only going to feed on plant material. Okay, they're herbivores. Your third trophic level are your secondary consumers, and they are heterotrophs as well, so they can't make their own food. Some of these secondary consumers, this third trophic level, are your secondary consumers. They might be carnivores, like a snake is only going to want to eat, a mouse or some kind of meat. I don't know of snakes that really want to eat lettuce. But some of these secondary consumers can also be omnivores, which means, again, a bird might be here. So a bird might feed on a grasshopper, or it might feed on some seeds. So your third trophic level, which are your secondary consumers, don't get those numbers backwards, okay? These can be omnivores, or they may just be carnivores. And then your fourth trophic level, which are your third or highest level consumer, your top level consumer, your fourth trophic level. These are your tertiary consumers. And I spelled it out kind of phonetically here for you, tertiary. These are carnivores. They don't want no plants. They want some meat. This hawk wants a snake, or it wants a rabbit, or it wants a smaller bird, or it wants a fish, but it does not want meat. Okay, so as you move up, your first trophic level are your producers, your second trophic level are your primary consumers, your third trophic level are your secondary consumers, your fourth trophic level are your third or tertiary level consumers, only want meat. All right, so here we have another, little energy pyramid. We have our producers eaten by our primary consumers. These grasshoppers will only eat the grass. The secondary consumers, the birds here, which is your third level up. This is your first level, your producers. Your second level, your consumers. Your third level, your primary consumers. Your third level are your secondary consumers. These birds might eat grasshoppers or some seeds, so they might be an omnivore. And then your tertiary consumers only want meat. Okay. All right. So another little food chain. Grass is eaten by a grasshopper, which might be eaten by a mouse. But that mouse might also eat, seeds and acorns and nuts and things like that. So that would make it an omnivore. And then the owl would eat the mouse. Poor little mouse. All right. If you look at this food web here, we'll get to that in just a second. But if you notice all these brown arrows, what do you think they represent? I know this is hard to see down here. It's kind of blurry, but these brown arrows basically represent the fact that all living things, when they die, that's when your decomposers take over. Decomposers are important because they break down dead matter into nutrients, which enter back into the soil or back into the environment. So really, decomposers turn dead animals and stuff into fertilizer. That's really about what it amounts to. Okay, more nutrients. Plants or producers can then take up the nutrients through their roots. Decomposers are usually not shown in a food web because they don't contribute any energy or any food really to an ecosystem, but their role is critical because it's important that those nutrients go back into the environment for other organisms. So don't leave out the decomposers, even though they seem insignificant. Those bacteria and fungi, those things, they are very, very important. All right, food webs show many interconnected food chains, and they really are a more accurate representation of how energy moves through an ecosystem because most organisms eat more than one thing. They might be in trouble if they don't. If you have mice that only eat grasshoppers and they won't eat anything but grasshoppers, and let's say that a virus kills all the grasshoppers one season, well, then the mice don't have anything to eat, so the mice are going to die because they're going to starve to death. And then the things that eat the mice are going to have less food. So it's important that organisms, have more than one thing on their menu. that they're not too picky about what they eat. All right, so here's a food web, and you can see lots of different interconnected food chains here. For example, this grass might be eaten by this grasshopper, which might be eaten by the shrew, which might be eaten by the hawk. Or that grasshopper might be eaten by an insect-eating bird that's eaten by the hawk. Or the grass might be eaten by the rabbit that's eaten by the snake that gets eaten by the mountain lion. Although I've never actually seen a lion eating a snake before, but I'm sure desperate times call for desperate measures. What do you notice about the arrows in the food web? If you look closely at them, what you should notice is that the arrows are always pointing toward the thing that's going to eat the other thing. In other words, they're always pointing up the food chain from what's going to get eaten to what eats it. Okay, so arrows always go up the food chain. Everybody say up, 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 up. Arrows always point up the food chain from what's going to get eaten to what's going to eat it. From this grasshopper that's going to get eaten to the shrew that's going to eat it. From the shrew that's going to get eaten to the hawk that's going to eat it. So arrows always point up the food chain from prey to predator, prey to predator, prey to predator. Okay? All right, flow of energy can also be illustrated using energy pyramids or ecological pyramids, but we're going to focus on energy pyramids. So in an energy pyramid, it just represents the energy that's available for each trophic level. Okay, and of course, energy, we're talking about food, right? So if we look at this energy pyramid here, what would happen if there were so many grasshoppers that they ate up all of this grass? Well, they're going to start to die because there's going to be no food for them. So organisms that feed on them are going to have less food. And so it's very important that you have more organisms, near the bottom, and they'll decrease as you move up. But remember that these organisms are food, okay? And so we need to think of them as food, and food equates to energy. So as you move up through an energy pyramid, if you look at these numbers, down at this lowest level, which is your foundation here, your plants are your producers, there will be 1,000 kilocalories of energy. That's a unit of measurement for energy. Notice that only 100 kilocalories of that gets passed up to your primary consumers. So they only get 10% of the energy that the trophic level below them had. Okay, as you move from primary to secondary consumers, drops from 100 to only 10. So only 10% gets passed up from your primary to secondary consumers, or from your second to third trophic level. So the amount of energy is decreasing. And that equates to food. Okay, there can't be so many shrews that they eat up all the grasshoppers. And there can't be so many grasshoppers that they eat up all the grass. And there can't be so many owls that they eat up all the shrews. If anything on here gets out of balance, the whole thing's just going to collapse. So in a healthy ecological pyramid, this is kind of how it has to work in an energy pyramid. There's more food or more energy available at this bottom first trophic level than there is in the one above it. So there are fewer organisms. There are more organisms available here than at this level. And so, these organisms, if they were to eat up all of these, then this might grow out of control. Everything gets kind of wonky if these numbers kind of get messed up. So this is how it needs to work. The smallest section of the energy pyramid, those are your tertiary consumers, your top level consumers, your fourth trophic level. They really are going to get the bum end of the deal because they have to work a lot harder to be able to find, their food. Okay, the energy and caloric needs of organisms increase. So if you think about plants, all they have to do is sit there and absorb sunlight and take in their food, and they don't have to run away, and they don't have to chase down their food. Now, if you think about the grasshoppers that eat them, these grasshoppers do have to exert some energy because they have to fly to where the grass is, and they may have to fly away or jump away from predators. So they do have to exert some energy in order to get to their food, not to chase it, but in order to get to it or to get away from something hunting them. Then when you move up to your secondary consumers, your third, trophic level, these organisms do have to chase down their food. They have to catch it, and they have to evade predators. So they have to be able to run away. And, they have more complex life processes. As you move up to your fourth trophic level or tertiary consumers, they really have to exert a lot of energy. They have to chase down their food. Sometimes they may run a mile or two if it's a cheetah or something. They have to exert a lot of energy just to catch their food. They are in competition with other animals for their food. They have to escape predators as well. So your tertiary consumers have to exert a whole lot more energy. They require a lot more energy than, say, your primary consumers, but look at the amount that's available. 90% gets lost from one level to the next. Only 10% of energy gets passed up, meaning there are fewer and fewer organisms. There's less and less food as you move up. So let's say that this little energy pyramid we're looking at, this ecosystem here on this energy pyramid represents, a half an acre, square acre, or something like that. What that means is that this is how much grass will feed this many grasshoppers with some to spare. Okay. These grasshoppers will feed these two shrews with some to spare. And these two shrews will be enough food for a little while, to satisfy this one owl. So for every one owl, there might be two shrews to eat to keep it alive. And for every two shrews, they might need, 7 grasshoppers to stay alive. And these 7 grasshoppers may need, 1,000 pounds of grass to stay alive. There's less and less energy available, but the energy needs are increasing. So there are fewer things at each level. Remember that 10%. Only 10% of the available energy at one level gets passed up to the next. There are only 3 to 4 levels, trophic levels in an ecosystem, because each level uses and or loses about 90% of its energy. So only 10% gets passed up. There isn't enough energy to support, left to support organisms much further up than that. And the higher up on the trophic levels than an organism is, the more energy it needs. So this has got a lot of stuff on it, I know, but if you take a look at this energy pyramid, down here at the bottom is our first trophic level. These are our producers, and these are our green things. Notice that it's green. These are plants and phytoplankton and algae. And here is where you have the most organisms, so there's most energy available. Now, as you move up the energy pyramid to our second trophic level, these are your primary consumers. They're only herbivores, so they only eat plants. So these might be things like small fish or zooplankton that feed on algae and phytoplankton and plants. Notice there are fewer of them than there are here at your first trophic level. As we keep moving up, your third trophic level, remember that troph or troph means nourishment or food. These are feeding levels. These are your secondary consumers. And these might be things like birds or snakes. They might be carnivores or they might be omnivores. They might eat meat and seeds and plants and stuff. But notice there are even fewer organisms. This might be a larger fish that feeds on a smaller fish. Or these larger fish might like to eat algae too, so they might need to be an omnivore. As we keep going up to this smallest section, it's at the top because it does represent our top trophic level, your top consumers. And they are all carnivores. These are your tertiary consumers. But notice that these are the fewest organisms of all. So maybe only one shark would have enough to eat in this particular ecosystem if there were maybe 10 large fish, if there were maybe 100 small fish, if there were maybe 1,000, phytoplankton, that kind of thing. Keep in mind, as you move up the energy pyramid, the number of organisms decreases, so the energy available decreases. But the energy requirements of organisms increase as you move up, your energy pyramid, because now they're getting to a place where they're having to chase food and they're having to get away from predators, and they're competing for food. They're competing for mating rights. There's just a lot of complex life functions going on. Keep in mind that all of this begins with the sun, our beautiful, glorious sun. And I'm making this video on Thursday after it's rained for the last 3 days. So I hope to see the sun tomorrow, and I know you do too. All right, the main takeaways here: animals get energy from food, and energy moves through ecosystems by way of food chains and food webs. Arrows in a food chain or food web always point up the food chain, from what's going to get eaten to what's going to eat it, what's going to get eaten to what's going to eat it. So the mouse might eat the grass, but the snake will eat the mouse, and the hawk will eat snake. So arrows, always point up the food chain. I guess it would be good if I had arrows there. The higher up, trophic levels are feeding levels, and the higher up an organism is on the energy pyramid, the more energy it needs, but it's only going to get about 10% of the energy from the trophic level below it. Only 10% of the energy gets passed up from one level to the next. meaning there's less food available, so there are fewer and fewer organisms. So really this might be 3 mice for 2 snakes for, only 1 hawk kind of thing. All right. So if while you're completing the little Google quiz that's attached to today's lesson, if you need to refer back to the video, please do that so that you can get a 100 on that quiz. I hope all of you have a great day. Take care. Let your teachers know if you need anything, and we will talk to you soon. Bye-bye.